real fundamental thing that you want to be familiar with is the revenue and cost function, where you have profit, where you have loss, and where you have break-even points, and that kind of thing. So we talked about that, I think, on the previous problem. We have talked about marginal. And remember, if I'm asking for a marginal cost or revenue or whatever, I'm asking for a rate of change. So you're doing a derivative. Okay, now we haven't talked as much about average cost, so I'm going to talk a little bit about that. I think we've done a little bit with this, though, but we'll be doing more of that. So what you're doing is, like an average cost, you'll always see me put like a bar. That represents average, okay? Like in statistics, maybe you've seen like X bar means the average, okay? That's what that means. So the idea is you just take the cost function and divide by X. You're dividing by the number of things that you produce, so it's averaging out that total. That's the idea. And then marginal, well, I'm doing a derivative, okay? If you're doing average anything, you're always dividing by X. So if we're doing average revenue, it's the revenue function divided by how many things you produce, and so forth. Average profit, same thing, okay? So it's just taking that function and dividing by X, and then doing the marginal is doing the derivative. Okay, so that's what we're going to talk about. I got one more problem I want to do on this next page, and just kind of to illustrate that. Okay, so let's see. This one says you have a machine shop. It's making drill bits used in the petroleum industry. You estimate that the daily cost is given by this function. So this is a cost function right there, okay? So the first thing that you got to do on this problem is, before you think about, you know, the derivative and stuff on this, we're going to find C bar of X. So when we do C bar of X, what you always do is take the cost function and divide it by X. And then we'll simplify it, because when you do the derivative, you want to simplify it before you do the derivative. Okay, so you just start the problem off like that. That's all you ever do to get an average thing, is divide by the number of things you produce. Okay, all right. Now, if you're going to do the derivative on this, you would need to split it up. We've learned how to do this before, so that would be 1,000 over X, and then plus 25X over X, like that. And then minus 0.1x squared over x, like that. Simplify whatever you can simplify, then we can talk about the derivative, okay? All right, now what I would recommend on this is, if you do the derivative of 1,000 over x, what do you have to do before you do the derivative? You got to bring it to the top. So we might as well do that now. So we got 1,000x to the negative 1, okay? Because remember, that starts off a positive exponent. When it crosses the fraction bar, that changes sign, okay? What happens on the 25?
Nothing.
X is crossed out, so we got 25, so that's kind of cool. And what's x squared over x? X, good. If you forget the rule for that, x squared just means x times x over x. One of them crosses out, right? Okay, so that's going to give you minus 0.1x. So this is your average cost. That's the first part of this problem, is what the average cost is. Okay, and you'll do this pretty frequently in this class, is take a cost function and then write its average. Okay, then we're going to do the next thing. So what is the C bar prime of x telling you to do? Take the derivative, so we call that the marginal cost, right? Okay, so the second thing we're going to do is we're going to focus on doing the derivative. Okay, go ahead and do your derivative. Okay, you should be able, or hopefully you can do that in your head by now. And you just got power rule on that, so go ahead and do your derivative. And then this second part, we'll talk about what we're going to do with this. So what do you do with the derivative of 1,000x to the negative 1? Bring it to power rule. Bring the negative 1 down, and then what are you going to do with the exponent?
Minus 1.
Subtract 1. It always gets smaller by 1. Okay, so that you're going to go negative 1,000 x to the negative 2. Okay, what's the derivative of 25? 0. And what's the derivative of negative 0.1x?
0.1.
Negative 0.1, the number in front. Okay, all right, so we got, the derivative rules that we've learned so far apply to that. Okay, now I'm just going to clean this up a little bit, and I'm going to take this back to a positive exponent, so I'd say negative 1,000 over x squared. Then I'd have minus 0.1. So this would be the marginal cost, would be just getting that derivative and then writing that as a function. Okay, you don't necessarily have to change that to a negative exponent, but it's helpful to do that. Okay? All right, any questions about what I've done so far? So how do you do an average cost? What did I do? Divide by x. Okay, good. Okay, simplify it. Then when we do the marginal, then we do the derivative of each part. Okay? All right. So what we want to do from here now is on part B, we're just kind of doing the interpretation of this and everything. So if we do C bar of 10, what do you do with the 10? You plug it into the cost, right? Okay, that's not a derivative, okay? So what you want to do is just take this function, this is your cost right here, and plug it in. And you can use your calculator. So we'd have 1,000 times 10 to the negative 1, and then that was plus 25, and then minus 0.1 times 10. Okay, and then I'm just going to do that on the calculator. You can even do the 10 to the negative 1 on the calculator if you want to. You don't have to change that to a negative exponent. So you can just type it in one step, 1,000 times 10 to the negative 1. Okay, you can do it like that if you want to. Okay, and then it would be plus 25 and then minus 0.1 times 10. And as long as you get everything put in your calculator right, that should give you a result. So that is $124 is what I'm getting there then. Okay? Okay? All right, so that takes care of that. Where do I plug in the 10 on C bar prime? Where does that go? Into the derivative. That's the one that's in yellow. Okay? So when you do this, you would have negative 1,000. Okay, plug the 10 in here, so that would be over 10 to the second minus 0.1. Okay, and you can do it all in your calculator. I'm going to write this as negative 1,000 over 100. 10 to the second's 100 minus 0.1. If you divide 1,000 by 100, you get negative 10. Okay, like that. All right, so I'm not going to use my calculator, so that's just going to end up being negative 10.1, or in money values, it would be like negative $10.10. Okay, is it okay for the derivative to be negative? Yeah, okay, it's okay because remember it's a rate of change. That just means you're decreasing. Okay, something's decreasing at that point in time. So that's the idea. Okay, so if you can get your derivative okay, that shouldn't be too bad because you're just doing some arithmetic and plugging into the correct function. Okay, now we're going to write our interpretation. Well, that's one of the things we were kind of working on last week, I think. All right, so let's do the 125. Okay, so what this would mean is we would say, and you always start off kind of talking about your production level. So at a production level, we'll just abbreviate that PL, and these were drill bits. Okay, so we'll say at a production level of 10 drill bits. You need to tell me what things mean in the problem. Okay, at a production level of 10 drill bits, that is the average cost is $125 per item. So we would just say average cost in producing, and you can leave this up, but it's good to say in producing the 10 drill bits, I'll just abbreviate that DB, is $125 is what that average is, okay, for those overall 10. That's what the idea is, okay? All right, now let's see. Let's look at the derivative now, okay? So we're going to start the same way. We're going to say at a production level of 10 drill bits, and that needs to be written on there like that. You always want to kind of start that way because the derivative depends on how many things you produce, okay? Then what we would say on this is we would say the average cost is decreasing. Why do I say decreasing? Because it's negative. Yeah, so we say is decreasing at, and you don't have to say negative, you just say at $10.10. And I think these things are actually per day. If you read the problem, I was going to kind of look and see what that problem said there. I think it said something yeah, it's daily cost. So you really should say per day on both of these, okay? Same thing even with part 1. It's $125 per day because that's what the problem says. Okay, so the 125 just means at that point in time, you're producing 10 drill bits. It costs $125 a day for that production, okay? And then this is telling you, the marginal's telling you how everything changes. So at this point in time, the cost is decreasing, which is a good thing, right? You want to get to a point in time where your cost is going down per day, if you can, okay? Okay, so the other thing we're going to do is this last thing we talked about here. This says, use the results in Part B to estimate the average cost per bit at a production level of 11 bits per day. Yes, go ahead.
The average cost, where you got 125, we got 124.
Yeah, it's 124.
Is it 124?
You said 124, but you're 124.
Oh, yeah, it is. Okay, yeah, sure enough. Okay. I don't know why I did that. Did I even do that on my calculator? Yeah. Okay, those are the kind of things I do all the time. Okay, thanks for pointing that out. Okay, so everybody good with everything what I did on that problem now? Okay, very good. Okay. Okay, so let's see. Now this one, what we're going to do is I would recommend that you write down this formula. This is what we were talking about last time. So when you have and this will apply to C bar. So the marginal average cost of an item is approximated by the total average cost of the next item, and then minus the average cost of X like that. That's what we were learning last time, is how you do how you basically do an estimation. So here's kind of how you would do this then. Okay, you're going to use the result we got in Part B to estimate the average cost of the next item. Okay, so it goes like this. Okay, I'm going to let that be 10. Well, that's going to be 10 plus 1, like that, and then that's going to be the 10 like that. Okay, I'm just going to show you how this kind of works out then, all right? So the idea with this is with this, we're going to end up having like C bar prime of X at 10 now. Well, I need to write this like this, not like that. So that's going to be C bar prime of 10, which we already figured out in the last problem. Then we're going to look at the cost of the 11th item, and then we're going to look at the cost of the 10th item like that. Okay? So what I'm going to do is just kind of show you how this works out in this problem, and show you that the estimation is pretty close anyway. Okay? So what did we get for C bar prime of 10? We got, I think, negative $10.10, right? So that's what we got there. So what I'm going to do is just show you that how this formula works like this. So if I want to do C bar of 11, where do I go? Do I go to the derivative or just the cost? Just the cost, okay? That cost function, let me zoom out on this a little bit, is this thing right here that I got in blue. Okay, so we're going to plug the 11 in here. Okay, so what I'm going to do is I'll have you go 1,000 times 11 to the negative 1 plus 25, and then minus 0.1 times 11. And we'll do that on the calculator like that. Okay, so what that's doing is that's given the average cost of 11 items. Then when I do the 10, I do the same thing. All right, I just do plug the 10 in, so I would have 1,000 times 10 to the negative 1 plus 25, and then minus 0.1 times 10. And you're just going to do each part of that on the calculator. So what you're showing on this is the marginal at 10 drill bits should be close to the average cost of the 11th item. And this is what you guys are going to make sure you understand. A lot of times students don't get this. When I say C bar of 11, you know what? That means the average cost of all 11. It doesn't mean the average cost of the 11th item. Same thing here. C of 10 means the average cost of the first 10. So what happens when you subtract those? What do I really get? I get the cost of the 11th item, right? See, that's a total for all 11. That's a total for all 10. So when you subtract them, the result of this is going to be the average cost of just the 11th item. That's what we talked about last time. Okay? Now, let's see. I'm going to put this in my calculator. I'll be kind of careful this time. Make sure I write this down okay. So the first one I'll just do, we already did actually the second part. So I'll do 1,000 times 11 to the negative 1. Okay, then I've got plus 25. And then minus 0.1 times 11. So watch me carefully and make sure I write this down correctly this time. Okay. All right, so that is kind of making sense. Okay, that is 114.81. Okay, that's what I'm getting there.
So why we just don't plug the 11 on the derivative?
Talk a little louder. I'm having trouble hearing you.
So why we don't plug in the 11 to the derivative of that 10 to get
what I'm going to do is show you that the answers are similar. So remember, we already did C bar prime of 10, and we got negative 10, 10.
Yeah.
Okay. What I'm showing you is that will be close to the average cost of the 11th item.
Okay.
These things are going to be close. They'll be off by pennies. We did a little bit this last time. Okay, so that's how that goes. Now remember this part right here. We already worked this part out. Remember what that was? That was 124. We already did that. So what I'm going to do is subtract these two numbers, and let's just see how close they are. So if you do this, I think you probably, maybe it may only be off by a couple of pennies or something. So I'd do 114.81 minus 124. And okay, that's off a little more than I thought, but that's still okay. It's negative 9.19. So the idea is, see, these things right here are pretty close. Okay, so a lot of times what you do is when you interpret what the meaning of that marginal derivative is, or the marginal cost at 10 is, it's almost the same as the cost of the next item. That's the idea. Does that make any sense to you? Okay, all right. That formula is something that's pretty important, okay? And when you have your test on Thursday, I'll mention this right now, but one of the things I let you all do is bring in half sheet of your own notes. So that would be a formula that I definitely try to remember to write down, okay? Because I don't want you to get that backwards. It's just the derivative approximates the exact cost of the next item. That's why you do that. Okay, and then you'll see that those things turn out to be relatively close to each other. Okay, all right, sometimes it's pennies, sometimes it's $1, but it's relatively close.